Okay, we're going to get started. I hope that everybody can hear me. If at some point we have technical problems and you cannot hear me, please say something in the chat window. So for those of you who already took COP2513 with me online, you know how I'm going to make this work. I'm going to keep an eye on the chat window, try to do it at all time, so that I can answer question. Okay, thank you. I'm glad to see that you can hear me. So I'm going to keep my eye on the chat window at all time. Feel free to just dump questions there. Anything that you can think of, ask question there. Just type it out. Same thing if it's going too fast, too slow, etc. You can use that to communicate with me. If I miss something, because I do miss occasionally, a comment or something like that, what I try to do, I pause every few slides or something like that, and I catch up with the chat window if I feel that I've been falling behind. Okay, so we are going to try to get this to work the best possible way that we can. All right. Before we jump into the lecture itself for today, let me talk a little bit about the exam IE0. So I got a lot of Canvas message about IE0. Some of you, unfortunately, had to go through some technical problems. So this is always like adding stress to the stress already of an exam. So I'm sorry for that. But I'm still working through answering the most recent messages that I received. So you should hear from me, I would say today. Okay, like in between the two classes, there's the morning and afternoon session, I should be able to catch up with everything that's left. So you are going to get responses today. For those of you who have technical issues, don't worry. I always try to work with the student to resolve those issues. Okay, the line is pretty much when you open the exam, then you're like using your attempt. But if you cannot open the exam, then I'll work with you, to make sure that you can actually access it in the next day, like today or tomorrow or something like that, and take it, okay, in good conditions. I think we had like 2 or 3 students who were bothered by the password bug again. So one of them was resolved, or 2 of them were resolved. One of them is still going to open a ticket. So this is where we stand right now. And yes, Robert, we are back on good old Blackboard Collaborator. That brings back memories. Okay, so other than that, here's how we work for feedback on the exams. So we had our first graded intermediary exam, IE0, all right? The TAs started already grading them. So you are going to get your points, your grades, your rubrics, and your feedback within a week. That's the deal that we have with the TAs, okay? And as soon as you get that, as soon as everybody is done, going through the exam, because some people have a few days of how to say, extension for medical reason or otherwise. So as soon as everybody is done going through the exam and everybody has received their feedback, then we open the doors to talking openly about the exam. Before that time, I don't address the exam during the lecture, and if we have to talk about the exam, we do it one-on-one during office hour. We do a little side session, something like that, a breakout session, and we talk one-on-one because we don't know who in the room has taken yet the exam, who hasn't. Well, we can know, but it's not really practical, okay? So once we get to that point, the important thing for you to do is don't just take your grade and the feedback that the TAs are going to leave you as text, in the speed grader. Don't just take that as the final word on the exam. It's just a discussion starter. If you lost points, we try to explain to you why you lost points, but then we expect you to come to office hour, and more specifically the office hour of the specific TA that graded you, and discuss the feedback until you understood everything that you did wrong, and you're not going to do it wrong again for the next exam. Okay, very important. That's how it's going to get better and better. That's how you are going to get better and better throughout the semester. Okay, so if I tell you, for example, if I was leaving feedback on an exam and I told you lost 2 points here because this and so, well, generally the feedback is terse, right? So you don't want to just use that and try to figure out by yourself, what you should have done instead. Come to office hour, talk to me if I am a grader, and we are going to dig into the feedback. Plus, there is an added benefit, okay, and it's not necessarily a small one, is that if I made any mistake, or one of the TA made any mistake, right, we are going to realize it. We are going to give you back the points. So it's a way to double check that there was no grading mistake, and to make sure that you fully understand, why you lost points, and even more important, how you're going to avoid losing points for the same reason in the future. If we do that little cycle where you guys come and get feedback and pretty much work on your exam, after it's done with the TAs and stuff like that, generally it's really beneficial for students. You're going to see a steady improvement of your skills. Last thing I'm going to talk about real quick before we jump in the session itself is I had a few students contact me saying, you know what, IE0 was not at all what I expected. Pretty much I need help. That's the goal for IE0. The IE0 is we had we are in our third week, right, of doing progressively things that are more and more related to this course. Okay, we spent 2 weeks for sure doing reviews, and now the last lecture was a gentle link between the COP2512 Java and the Java we're going to write in this class. So we are ramping up slowly things to give you time actually to catch up if, for example, you never saw Java in your life. But the deal is that during this time, again, you have about, let me think, 23, 25 hours a week of office hours between all of us, like the TAs and myself. Use them. These can be like 25 hours of tutoring. If you need somebody to work with you on the fundamental, we're here. If you need somebody to help you learn this Java syntax, compared to Python, we're here. Most of us have been doing at least a little bit of Python. We should be able to bridge the gap for you between the two languages, okay? So bottom line is that if you already, and some of you already use the office hours, perfect. If you didn't use the office hours and you didn't get like the result you expected for IE0, well, don't freak out, okay? This is why we have so many office hours, but start using them now, okay? You're going to get some negative feedback. You're going to get a grade that you're not going to like, maybe. But if anything, this is, a self-assessment, wake-up call, whatever you want to call it. And now it's going to put you on track, to get better for the rest of the semester. All right. So this is pretty much everything that I had on my slate here that I wanted to discuss before we started the lecture itself. Please hang around at the end of the lecture. You saw my announcement on Canvas. While we are going to be online, I'm going to do what I found out in the past was working the best for the online format, and I hope it's still, I'm crossing finger, I hope it's still working, this semester, because sometimes population of students change, their need change, etc. But we are going to have the office hours right after the lecture. So for an hour 15, I don't remember, an hour and a half, whatever it takes after the lecture, I will be hanging around. Stay connected, hang around 5 minutes if you have a small question, hang around the whole time if you need a lot of help, okay? And I'm going to address other questions that you might have about IE0, etc. during that time as well, all right? Okay, for now, let's go back to the topic at hand for today. So I have a lot of windows because unlike what I was doing last semester, that we had this COP2512 online, I'm using both Panopto and Blackboard Collaborate. So this is a juggling act, and I apologize in advance for the little delays and mishaps that are going to happen whenever I switch between things, okay? Because they are going to happen, I know that. So what we have right now, is the lecture 2 in module 1. So module 0 was a review. Module 1, lecture 1, which was the last session, we discussed about pretty much this is how we used to write code, and now this is how we write code we are going to write code, in COP2513. And we just saw a quick example at the end where we stretch, that poor Hello World, that greeter class that does very little, and we kind of stretched it all the way through the different things that we learn in COP2512, and we started doing a class with actually an attribute, the greeting message was recorded as an attribute in the class, and so on and so forth. Okay, so this is where we stopped. So before we go to the next syntax that I want to introduce and concept, just to clarify, because I didn't used to use those few slides that we are going to go over, and I had a lot of questions from students about, yes, I understand what you're talking about, but I don't understand why we bother with this. So I added a few slides here at the very beginning of our second lecture in OOP, just to clarify pretty much why is object-oriented programming even a thing? Okay, why did we go through that track of different styles of programming from COP2512 up to now, and we are going to continue in that direction? So the answer is pretty intuitive, actually, and I would say, not being an expert in object-oriented programming or anything like that, I would say from my own personal perspective as a programmer, object-oriented programming is indeed very intuitive because it has, how to say, strong foundation in how we perceive the world as human being, I would say. So let me try to be less vague than this, and let's give you something concrete to look at. Okay, the example that I like to always use is graphical user interfaces. So you and I deal with GUIs everywhere all the time. Okay, anything from the mobile graphical user interface of the apps on the phone to the desktop application to the web pages that we browse. Okay, they are now web applications. They have their graphic user interface, etc. And they share, all of those share a lot of principle. Okay, those of you who are ever going to take a human computer interface course, you're going to discuss pretty much user experience, user interfaces, how to make the best user experiences possible, and so on and so forth. So all of this is as a shared core. But from the programmer perspective, there is also a shared core to all of those problems. The problem of developing an Android interface, the problem of developing an iOS interface, and so on and so forth. And it all boils down to one word that I love that word. I don't know why, widget. Okay. When you look at this, for example, here we have, I don't remember what a screenshot is. A screenshot JGrasp, obviously, so that's a desktop application. And that one was a web tab on, and I don't remember the name of that product. Maybe it was Code.io or Replit. It's a website pretty much that allows you to do your development entirely in the browser, and it's used a lot, mostly for teaching and stuff like that. So we have two different type of programs on the slide here. One is a desktop application written actually in Java. JGrasp is written in Java, and the other one is like a web application that's probably written using one of the available stack, involving, maybe depending on the stack, multiple programming language and stuff like that. What do you notice in both of them? Well, they have the equivalent of physical object. It's something that we can look at, okay? And I can say, for example, here, where I'm putting my laser, I have a menu button. And here I have a menu button. And the behavior in both cases, you click the menu button, there's going to be a pop-up window that's going to scroll down, and you are going to be able to select one or several options, right? And maybe some of the options are, in turn, they let another menu roll down, and you can select another option in there, and so on and so forth. You guys know how this works, right? You have been using those GUIs, all of your life. So what is the point here? Well, the point is that I can break down the job of writing a graphic user interface like this one by saying I need to have some code that allows me to capture everything there is to know about, for example, a menu button. And then here I'm using, on the left side, I'm using a tree structure, right? I can have items, and if I click the little inverse hat button here, I can see what's inside that item, and then if I click again, I see what's inside the sub item. So this is also a widget, okay? A menu button will be a widget, a menu bar will be a widget. This here will be also a widget. And guess what? If I want to use it here, or if I want, for example, to have like a file browser that is tree-like, in JGrasp instead of the default one, I would be using the same kind of widget over and over in different application, in different even language, in different context. Okay, so those things, those widgets, they're like physical objects. Okay, I can have one menu button here, but once I know how to create a menu button, I can kind of use the recipe that I use to create the file menu button here. I can use it as a template to create the edit menu buttons, the find menu button, and so on and so forth. Okay. Same thing for the icons here. If I have code that allows me to manage, for example, the add something icon here or the compile icon here in JGrasp, if I want to another icon, then I can use that same code as a template and create another icon and then manage a series of icons as a series of objects. And this is where the term object comes from. Okay. An object in object-oriented programming is kind of like what an object is in the physical world. In the physical world, I look at my desk and I have several objects that I can manipulate. The objects fall into categories. For example, if I had like 5 phones spread out on my desk, which I don't, not that crazy, but if I have 5 phones spread out on my desk, right, each of them would be an object, but they would all follow the template of a phone. So now we introduce the concept of category of object, which in programming, we have objects that are entities that are going to be code pretty much. And we have also the concept of template. We call it a class. So a class is simply, a template that tells me what makes every single menu item here in terms of code. Okay. And if I want to have several menu items, I just, pretty much reuse that template over and over again. So this is really what started actually object-oriented programming, not necessarily the graphical user interface, even though building graphical user interface in object-oriented programming has always been a thing ever since the inception of OOP. But also the idea of simulating the real world, maybe making simulation of traffic and stuff like that. Well, you would model actually your problem by saying, well, I have a highway is going to be an object, and on that highway, I can have cars that move at different speed. So now I'm going to model every vehicle, by an object of type, vehicle, for example. And then I'm going to think about what constitute a vehicle. What do I need in my simulation of traffic, on highways? What do I need to store inside a vehicle as far as data goes? What do I need the vehicles to be able to do? For example, render themselves on the screen, draw themselves, maybe animate themselves on the screen, stuff like that. So we are having like this idea that suddenly we have a name to call reusable entities of code that represent, that model either something like very physical, like for example, a vehicle in my simulation or a button in my graphical user interface, but also sometimes things like bank account or some things a little bit more abstract, right? So this is a very natural way to look at the real world first. And by extension, it's a very natural way to look at, how I'm going to break down the complexity of a huge application into smaller components that I can then reuse, use multiple times if they are the same category and stuff like that. So all of this is possible because of the idea of class. So objects make sense because we have the idea of class that tells us, okay, all those widgets, they share the same data, they share the same behavior. So data is going to be variables that we store inside the object. Behavior is going to be methods that we store inside the object. So we already know how to store data in a program. We use variable. We know how to store behaviors. It's methods. So now what we are doing is we are simply saying that we can group together a set of method and a set of variables. Okay, we can call this a class. And then when we want to create an object of that class, for example, a button that we can click on in the user interface, right? We just say, I want to create an object of the class button, and immediately that object on the screen is going to have access to all the methods of the class, and it's going to contain inside of it all the variables that are listed. So each different button in my user interface, for example, is going to have a variable, let's say, state, that's going to say if it's pressed or if it's not pressed. Okay, it's going to have a method toggle that's going to allow me to switch between pressed or not pressed every time I click on it. You see how this is working? So we have the general template. It's something kind of abstract. This is how a button works. Okay, and then we have instantiation, concrete instantiation of that template, which is when we create object, and those objects can do everything that is in the template and store inside of them all the variables that have been defined in the template. And that's pretty much the essentials of object-oriented programming. Not too complicated, okay? This is using stuff we have already used in the past. This is just like wrapping it with a nice bow into the idea of a class, okay? So I already introduced that distinction between the two things that we want to find actually in objects and classes, right? The behavior, that's method, the state, where you're going to hear me talk about the state of an object. That just means the state of an object is when you take all of the variables that the object contains and you look at their value, okay? So together, all the values of all the variables that an object contains represent its specific state. For example, a button could have a color variable inside of it that says the button is background red, the text is white. Then it could have a variable that tells me what the text is. The text is okay, for example, for that button. Then a variable that tells me the status, is it pressed, is it not pressed? Well, all this together would characterize pretty much the state in which that button is right now. So we refer to it as just the state of that object. All right. So I put like some easy definition here. All of this is stuff that most of you probably already heard in one form or the other. I've been using the term object in COP2512 and in the first week here of COP2513. The only difference is that I used it very informally. Okay, now we're starting to kind of dot the I and slash the T's. Okay, so in that spirit of let's be more and more formal, let's be more and more detailed. Let's talk about the difference between class and objects. Okay, so one is a template. One is an actual code entity. Let's call it that way, right? It has variable inside of it, and it has methods that it can use. But all those variable and method have been listed when we define the class. So what I'm about to tell you is not true in every programming language. Most notably, since so many of you were how to say exposed to Python, Python does things completely differently. But in Java, a class is something that is pretty much in the source code. So you write the definition of your class in the source code. You say every object of class button is going to have we call them attributes, so those variables inside the object, right? It's going to have an attribute that's going to tell me what is the color of the background for the button, what is the color of the foreground, the text, what is actually the text that needs to be displayed in the button, and whether the button is pressed or not. I'm going to use, for example, a Boolean. Okay, so I would declare all of the variables like that in the class. I would give you the code for all the method that the button is supposed to be able to execute on itself. And all of that is at the declaration level. Okay, so I'm just writing source code and nothing is happening right now. I'm just declaring this, declaring that. I'm pretty much telling you, this is how a button works. This is how a menu item works. This is how a scroll bar works. And I go on and on and on. I give you a ton of class like that. But nothing happens yet in memory. Then we compile everything. So we make sure it's correctly spelled, that the Java grammar is correctly used, right? And then we generate the .class file. That's the result of the compilation. And finally, when I try to run my code, I take all of those .class files, which are the translation in Java bytecode of all those declarations, okay? And then I look for the main method, and I start executing the first statement inside the main method, okay? And now things are happening. So now, for example, if I want to display on the screen, that user interface that I keep talking about, I'm going to say, I want to create an object of class menu bar. And now I want to create an object of class menu item for the file menu item, pretty much. And then inside of it, I want to find this and this and this and this. So I'm creating my user interface at runtime. Creating user interface means creating an object. Creating object means I go and say, you remember that template that I defined that says what all buttons look like? Well, use it to create an actual button. And the term actual here is very important. The objects are what is actually existing in the Java memory. That's what's actually created. Okay, so these are our unit of code, if you will. They are going to have variables inside of them. They're going to have a bunch of methods that we can execute on each of them. Okay, and what's available is dictated by the declaration in the source code, but it only happens during runtime. It becomes usable during runtime. So there is an abstract version, which is the template, the class, the source code, and there is a concrete version when things actually happen, when the code is running, which is the runtime, and this is where objects are created. And like I said, this is true for Java. And for this class, this is all we care about, okay? But just so that you know, other programming language, they kind of blur this distinction between what happens at, we call it compilation time, or when you are writing the code, the source code, and what happens at runtime. And it's actually very interesting. This is super interesting from a programmer perspective. You can do things that are really amazing like that. But for this course, we are going to focus on the basic scenario, which is, pretty much we have this clear separation between what happens in the source code and then what happens when we run the source code, runtime. All right. So I tried to go as fast as I could through those definitions because I'm pretty sure that at some level, at some informal level, the vast majority of you were actually familiar already with those concepts. Okay, so I'm hoping if you were not, hang around a little bit at the end of the class. Let's talk a little bit. Let me make sure that you are comfortable with all those concepts. Okay, it's very important because now we're going to keep using those words again and again. And even if even if you are only 90% sure of the meaning, then that 10% is going to snowball into misconception and difficulties understanding what we are going to do in a few weeks from now. Okay, so make sure that all of those concepts are clear. Take the time to ask questions. For now, we are going to try to go from vague discussion about concept to actually concrete example based on code. So this is what the next series of a few slides is going to do. We are going to look at an example of how to write, two examples actually on how to write classes and how to use them to create objects. Okay, and last lecture, that's pretty much what we finished with, but we did it like in the last 5-10 minutes of the lecture. So I just used the example of that greeter class. That was okay. That was a good way to finish up, the last part, but we didn't really take the time to go in detail. Now we're going to take the time to do just that, go in detail and explain everything there is to explain about the process of creating objects and declaring classes. So the first slide is going to tell you about a notation. So nothing transcendental, okay? Nothing really conceptual, or technical. It's just like a notation that we like to use. The textbook definitely likes to use it a lot, okay? And by the way, every single exercise in the textbook, almost every single exercise, asks you to draw something called a UML diagram, right? So I'm going to finally explain what it is, but when I recommend that you do some exercise from the textbook, you don't have to draw the UML diagram. In this course, we're going to use that UML diagram notation just as a way to illustrate things on slides and in the textbook very easily, okay? But I'm not going to ask you to draw UML diagram. I'm not going to give you UML diagram to work with, okay? This is just a tool for us to communicate and to explain things in a visual manner. So what is that UML thing? So UML is an acronym. We are in a field where we all love very much our acronyms. There are like a ton of acronyms right and left. So UML stands for Unified Modeling Language. For those of you who are a little curious, I put the Wikipedia link. It's a good starting point for learning a little bit more about UML, okay? And what it boils down to is those boxes that you see on the slide, okay? So what do those boxes represent? So what you have in front of you here is called a UML. There are tons of different diagrams in the standard for UML, okay? We are going to look at the two simplest type of diagram, which are called class diagram, and we're going to look at something that's going to be, we're going to call it an object diagram, okay? So as the name kind of imply, UML class diagram is going to be a graphical representation, a visual representation of a bunch of classes. In this case, we have only one class, okay, but we could have like a graph, with a bunch of classes with lines between them, and we're going to learn progressively what this whole notation means. What happens when you draw a line between two classes? What does that mean? Well, let's start simple. Let's start with a diagram that has only one class, and then we'll talk about relation between the classes. And then similarly, we can represent what's happening in the memory of our application by showing, for example, that in this case, I have 1, 2, 3 object of the class. The class name is simple circle. There we go. So I have 3 objects of the class that exist in memory. I represent them just as box. Okay. So Jonathan said, I read about this, but didn't try it in Java yet. So UML, I should have mentioned that. So I'm glad that you brought up that remark. UML is actually, how to say, it's programming language agnostic, meaning that it doesn't care about any specific programming language. It's not something that's particular to Java. It's not particular to Python. It's not particular to C Sharp. It's kind of the opposite. It's a way for people that potentially program in different programming language to still be able to get around a table and draw a diagram that explains the overall structure of their object-oriented application. See what I mean? So it's kind of a way to abstract the detail of programming in a very visual, graph-like representation that everybody can understand. So it has its own convention for notation, for syntax, and we're going to talk about them like briefly, okay? But again, I don't want really to teach you UML in detail. I just want you to know what it's there, why it can be potentially useful, and be able to read mostly a UML diagram, to understand what it's talking about. All right. So let's start with that UML class diagram here. So here we have one box that represents one class. The title, the name of the class, is going to be always at the top. So here we are following the Java syntax that says, use the camel case and start with an uppercase. So simple circle is the name of the class. And here it is. And then we are going to separate one way or the other the name of the class from what we call the attributes. And it's a time for me in the semester to issue that warning. Object-oriented programming, I told you already, we are in a field that loves acronyms, like UML, etc. Well, object-oriented programming is also a field that loves to introduce a lot of terminology, and this includes completely synonymous terms. So some people are going to say, for example, when I try to model what a circle is inside a class named simple circle, I need to keep track of what is the radius of my circle. Okay, so I'm going to pretty much have a variable named radius that's going to be declared here in the class, and that means that every time I create an object of the class simple circle, like here's an object, circle 1, circle 2, circle 3, each of them is going to contain a variable of name radius and of data type, whatever I decided to make it here. Okay, so this is a declaration of the variable. These are the actual variable, one per object. Each object has its own version of the variable radius, and they are completely separate. Okay, well, here's the jargon, here's the terminology part. This is called a data field. People don't generally call them variable. I use the term variable because you guys knew already what a variable was. So the concept of I have variables inside my object, that's something really clear to understand and an easy way to explain it, okay? But now we're going to force ourselves to use the correct OOP terminology. So a radius here is declared as being of data type double, and it's called a data field of that class. It's going to be also referred to as a data field inside each object. But not everybody calls this a data field. Some people call it an attribute of the class. And I'm pretty sure I could dredge up, a few more synonyms that people have been using at some point in the OOP literature. But for us, the two main terminology we're going to use are data fields, attributes. Okay? And then we have code. So this is kind of like what corresponds to data, okay? What kind of data do I need to store inside each object of the class simple circle? Well, just their radius. We're good. Of data type double, right? And then what kind of method does a simple circle object need to be able to execute? And here comes a list. So that's why when we declare a class in Java, right? So far we haven't declared many attributes. We did one at the end of last lecture, but you can, inside a class, you can declare a bunch of attributes, and then you can declare a bunch of methods. And some of you asked me several times, does it matter the order in which we declare the method in a class? Because it matters, right? If I do a println before to declare the variable that I want to print, I'm going to get a syntax error. The compiler is going to yell at me. Yes, inside the method, the order matters. But when you are writing a class, remember, it's kind of like a manifesto. It's like a declaration of everything that makes up a button object, or everything that's going to make up every simple circle object, for example. Well, when you do that, you just declare one after the other the method, and the order doesn't matter. So inside the class simple circle, we declare this, an attribute, radius, type double. We declare a method named simple circle. You'll notice that this is the same name for this method and the name of the class. So we're going to talk a little bit more about those special methods that just have the same name than the class, because these are called constructors. They serve a very, very, very specific need, pretty much, okay? So we're going to talk about them like probably at the end of this lecture, beginning of the next lecture. So here I have two of those methods. The simple circle method that takes no parameter, and the simple circle method, wow, I have two methods with the same name. Yep, that's okay. But that's okay as long as there's still a way to differentiate them. For example, the first version takes no parameter. The second version here takes one parameter called new radius of type double. Okay, so you see the syntax is not Java syntax, but it's not Python syntax either. So what is it? It's UML syntax. When you want to tell me that there is an attribute, you put the name of the attribute, colon, and then the data type. When you are trying to tell me the parameters for a method, you put the name of the parameter, colon, and then the data type. So again, the syntax here, if somebody doesn't put a colon here, but puts like another symbol, I don't care. I'm not going to have you write UML diagram, okay? But I want you to be able to read them, and I want you to understand that they are different in their notation from Java, from Python, from almost every other programming language, okay? Yep, the cat is back. Sam is still there lecturing with me. So those of you, again, who took COP2513, you're used to that. But for the others, it's going to be maybe a surprise. But yeah, it's going to show up from time to time. All right. Back on this. So would it be the same as double new radius or no? Yes, Jonathan. If I was to implement in Java what this diagram is representing, that's exactly what I would do. I would say double new radius semicolon. Okay, sorry, double new radius between the parentheses of my method to indicate that this is the parameter. Okay, but if I was writing it in Python, I would write it differently. If I was writing it in C#, different syntax. Okay, so this is kind of the minimal amount of syntax that everybody agrees on to describe what a class is. That's what a UML class diagram is. Okay, and there's a little bit more we're going to cover like in the following few weeks. Okay, and then I have get area, get perimeter. And how do I write in UML when a method returns something, a value? Okay, when it returns a value of data type, double or something like that. Well, I write the name of the method, get area. I put parentheses. That means, just like in Java, that means, hey, this is a method. And then colon, so that's not Java anymore, and double. So that means pretty much this method get area that takes no parameter returns one value of data type double. Same thing for get perimeter. It's the name of the method is get perimeter. What does it return? A value of data type double. And when the method returns nothing, like those two constructors here, there's just nothing at the end. I don't put colon and a data type name. Okay. And then set radius. Set radius is going to take a new radius as a parameter of type double, and then it's going to return void. So generally, when it returns void, we don't even have to put anything, but we can write colon void if we want, and that's it. Okay. So just notation, like a different syntax that's supposed to be the simplest way to communicate when you have, for example, a Java programmer who is trying to explain to a Python programmer and a C# programmer, what their application looks like. What are the classes in the application? What do the class contain in terms of attributes and in terms of method? Well, that's our pretty much, minimal language to communicate with one another. All right. So we will talk more about the constructor. That's going to be the next section, pretty much, of this lecture. Okay, these are methods. That's the first thing I always explain to my student. Constructors are just method, but they are special method. You heard me say that already with the main, right? For like an entire semester, I told you the main method is a method, but it's a special method because blah, blah, blah. Because, Java uses it to know where to start executing code in your entire application. Well, the constructors are a little like that. We write them like we would write almost a normal method, right? There's a little bit of syntax, extra syntax, but then Java uses them every time you create an object of that class. So the constructor, the name constructor kind of like, suggest the idea of building something. So every time you say, for example, I want to create an object of class simple circle, like for example here, my circle one, okay, is going to be the name of my object. So in Java, that would be a reference variable named circle1, colon, the type is simple circle. So in Java, that would be a reference variable that is meant to refer to an object of class simple circle. And when I want to create this, I use a new keyword, just like we did with new scanner, new string, and stuff like that. And when I obtain my object in memory here, these methods, the constructors, are going to be called automatically. There's a whole protocol, to determine which one we use and when and blah, blah, blah. And they're going to be called to pretty much finalize the object, meaning initialize it. For example, what is the default value for a radius? I don't know. So my constructor will know that. Is there a way for somebody at the very moment where they create an object to tell me, oh, by the way, this object, I want it to have a radius of, for example, 1.0. Yes, you give that information to the constructor so that the constructor can do its job, and as it finalizes the object, put the value that you gave as parameter to the constructor inside the attribute, the corresponding attribute in the object. Okay. So again, we're going to go drill down into detail, but you know how I like to do stuff. First, an informal view, kind of vague, description of what's happening. Then we drill into the details and we keep referring back to it. So that's a good time for me to transition to the bottom of this diagram here, because we kind of already did that. So at the bottom, I have like 3 objects. So this is a notation for object in the UML diagrams, right? So it's still a box, okay? There's still a box with on top, the name of the object, circle 1, the data type of the object, it's of data type simple circle. So circle 1 is an instance of simple circle. And then the list of all the attributes. We don't list all the method, or we only list the attributes and the value they contain for that object. So like I told you, it's like having variables inside objects, and each object of class simple circle is going to have an attribute named radius, its own attribute named radius, they don't share, and it's going to contain a value, and that value can be totally different, obviously, from circle 1 to circle 2 to circle 3. Okay. Now, why don't we list all the method? Simply to make it easier to read, because it's implied that if an object is of class simple circle, that object has access to all of the method that we define in the class simple circle. So all of this is implied. That's what it means to be an object of class blah. Okay, all the methods defined in the class blah are yours to use. Well, it's true also for the attributes. So why do we bother writing the attributes? Well, because for the attribute, we don't just write the attribute. We just don't say that each of the circle has a radius, which is a double. We actually tell you what is the actual value inside that attribute for that specific object. So this is worth keeping track of. That's why the notation is a little bit different. So that's how we would represent, and that's how the textbook actually represent the simple circle class using the UML notation. And then how does it look when we actually code it? So a programmer can very well be asked, here's a UML diagram. I want you to implement what this UML diagram represents. Okay. So the UML diagram is also a way for designers, architects, for code, to communicate to the various teams of programmer what they want them to implement. So in our case, the class simple circle is going to be super easy. Okay, so no trick there. But I'm going to use it as a way to illustrate, the translation between UML to actually code, and more specifically Java code. So we have a class, so we are going to have a file simplecircle.java, public class simple circle, okay, one public class per Java file. So now we're starting to take into consideration all the constraints, right, of Java, all the rules of Java. How do I declare attributes? Like this. like if I was declaring a variable, inside the class. So please note, double radius semicolon appears inside the body of the class. This is where the body of the class starts. This is where it ends, okay? But it's not inside any method. This is, I want to say this is the first time, but we probably saw one or two examples like that, okay? But we haven't used that a lot. Generally, when we declare variables, up to today, pretty much, the vast majority of the time we declare a variable, we declare it inside the main, or we declare it inside another method, okay? So the first thing to learn is, if you want to declare an attribute, declare it inside the class as a variable, but not inside any method. And that's it. That's just the Java syntax to do that. And then my simple circle method, so that one is a little special. Huh? Where is my public? Where is my static? Where is my void? Also, all of those are not necessary when you write a constructor. Again, we're going to talk about that in excruciating details, don't worry. But pretty much it still looks like a method declaration the way that I wrote them, until now, except this is way simplified. Okay, there's a lot of stuff missing. But here's the name of the method. Between parentheses, it takes no parameter, and then open curly brace, close curly brace, here's the code. And you see that every method is going to be true for every method in the class simple circle. Every method has access to whatever attributes are declared here. So it's a way of saying, a class is a way of saying, here are a few variables. We call them attributes, right? Every time you create an object, the object is going to contain those variables. And every time you run a method on that object, that method is going to be able to access those specific attributes that live inside the object. So everybody is going to have a radius. Every object of class simple circle will have a radius. And when I call a method, one of those methods that I'm going to define on a specific object, then immediately that method is able to read and write pretty much the attribute of that object. Okay, pretty cool. So here, I told you already, constructors are there to initialize things. So what is the default radius that I want to have? I choose that completely arbitrarily. I'm going to say the default radius is going to be always 1.0. So I assign the value 1 as an integer literal to the attribute radius. Because radius is a double, that's going to be converted to a double, so that's going to end up being 1.0 stored inside the attributes radius of whatever object I am constructing right now. And that's the thing with methods, right? Every time you write a method in a class, it's meant to execute on whatever object of the class. You don't know which object it's going to run on yet, but you know that at some point somebody is going to put the name of an object or the name of a reference variable in Java and say dot and then call the method. And that means run that code on the attribute that this object is holding. Double get area, same thing. So this one looks closer to what we have done so far in terms of method, right? So double get area is actually still not showing public and static. So you're going to see that we're not going to use nearly as much the static keyword. These are called non-static methods, the one we're writing. We had an example of that last lecture. We're going to drill into that a lot more. I don't have the public keyword again. We're going to drill into that more. But I have a method that pretty much returns a double value and takes nothing. And what does it do? Again, it accesses the attribute of the object on which it's called. And it's going to say, okay, you call me on a specific simple circle object. Let me look up what is the radius of that object, and then multiply it by itself, and then multiply it by the constant pi. And that gives me the area for that object. Okay? So think of the constructor as a method that initializes a field. Okay, we have been beating that point to death. Okay? The other methods, including the constructor, actually, technically speaking, the other methods that are not static, so which is both methods in this slide, they have to be called on an object. I also mentioned that. If you ever wonder, whether a method should be called on an object or not, okay, or must be called on an object or not, there's a simple way to tell. If it doesn't have the static keyword, that means it has to be called on an object. That's one way to tell, right? And there's another way to tell that leads to a deeper understanding of what the heck is going on. It's if you look at the code of your method and you realize that your method is referring attributes, is making reference to attribute. Well, we said that the attribute of that we define in a class, they are inside objects. So I have to have an object to be able to find its attributes. You see what I'm saying? I cannot say I'm going to get the area of what? All circles? That doesn't make sense. You get the area of one specific circle, right? So first you create an object of class simple circle, then you call the get area method on it. So the name of the object dot get area parentheses, okay, semicolon. And then the get area code is going to look up the value of the radius for that specific object, okay? How do I test that all of this is working? So we talked about that also a little bit last lecture, okay? I could, my first option would be, you know what? I'm not going to even create another Java file. I'm going to just add another method inside my class. So this main method here, just to be careful because this is a little confusing, okay? This main method here that is on this slide would be right here in between those two methods, or before the method, or before the attribute, or after the last method. But it would be inside the curly braces of the class. I close the curly brace here because that was one slide, okay? But that next slide, the code of the next slide, would be inside, the simple circle class declaration, but not inside any of the method. In Java, we don't have methods inside of method. Each method is its separate thing, one after the other, inside the declaration of the class, okay? Let me just finish this really quick, and then I'll address a question that popped up in the chat. So my main method, I just put it inside this class. So now this class has a main method, which means I can run that Java file. And what does it do? Simple circle, circle1. So I declare a reference variable named circle1, meant to be able to hold a reference to an object of class simple circle. I create a simple circle object, new. The keyword new is always about creating new objects. New simple circle. So I use the name of the class with parentheses after it. It's like I'm calling the constructor. Yeah, I'm kind of doing that, okay? I'm calling one of the constructors. And then once I have created the object, so the constructor initializes the radius to 1, then I can say the area of that particular circle, and I'm going to display circle1.radius. So I'm accessing inside the object that is referenced to by the reference variable circle1, right? I'm accessing one of the attributes. Okay, so I'm saying here's the radius of that object, and then I say compute for me the area of that object, and I display that as well on the screen. And then I can do that with a totally different object if I wanted. I could create another object, or I could go ahead and modify the radius of that first object, right? And then say, well, now that the radius is blah, then this is the area that I get. Let me stop here and switch back. It's a good point to make a pause anyway. Switch back to the chat. So could you get the area of all the circle with a method in the simple circle class for? Very awesome question. This is a very good question. Yes, we can do that. And this is when I'm going to reintroduce the keyword static. This lecture is pretty much when we beat to death the concept of static, static methods, static, we are going to see that we can have static attributes, right? We are going to explain pretty much everything about the static keyword. And yes, it allows us to do some things that are, for example, for all the object, of class simple circle, I want them to share an attribute. Or for all object of class simple circle, I want to write this one method that's going to exist and execute independently of any of the object that I created. Okay, so more about that coming up right down the pipeline. Very, yeah, it's a very cool programming technique too. That kind of blurs the line between when the class exists and when the object exists. Correct me if I'm wrong, and the book may have discussed this in the chapter, but could you call an element in a constructor like an array? So inside a constructor, you can have whatever parameters, okay? Parameters of type arrays of something, strings, scanner, primitive Java data type. So the parameter can be anything. Inside of a class, your attributes, that's another good question. Your attribute can be anything. So here, for example, I have a simple class, right? So my attribute is of type double. It's a primitive Java data type, but I could have an attribute of type string. So it's a reference data type. I could have an attribute of type array of doubles, array of strings, arrays of integers, right? So everything that we learn to do with variables, you can do it with attribute. So we could declare very simple variable, very complex variable. You can still do it with your attribute. So that means, going back to your question, that when you are inside, one of your method, okay, including the constructors, they can, I wouldn't say they can call an element. That's not the terminology I would use, but I would say they can refer to a parameter or an attribute that is of any possible data type, okay? And now remember, when you define a class, that becomes a data type. Okay, now that I define the class simple circle, I can declare variable of type simple circle. What does that mean? It's going to be a reference variable meant to hold a reference to an object of class simple circle. Awesome. So no pun intended, but the circle is complete, right? We went like all the way through. We learned to do some things with primitive data types, then we've referenced data type with variables. Now we put variable inside of class, but oh wait, now a class is a data type. So inside of a class, we can have attributes which data type is the name of another class, like a scanner S. Okay, and somebody was doing that in some of the practice exercise. I looked at that and I was like, hey, this is actually cool. But anyway, bottom line is everything that we learn to do on variable is applying pretty much to attributes right now. So that's how we scale up pretty much our programming techniques. So it's easier to refer to that variable than it is for an array in a way. Well, we use a dot notation. Every time you want to refer to something that is inside an object, you use the name of the reference variable, dot, and an attribute name, or dot and a method name. So yeah, it's in a way, it's actually, I wouldn't say it's easier to array, but it's mostly because I'm so used to arrays that I cannot, if I say it's easier than array, my mind just cramps and goes like, but arrays are not hard, that kind of stuff. But when you are just discovering this, yeah, I can see how the dot notation is more uniform, maybe. It makes more sense maybe than the array notation. That's kind of a little weird. Why do we use square bracket? Stuff like that. So, yeah. What else do we have? So we have our option for testing. I'm going to go fast over that one because it's going to be, once you understand the first example, the second is a repeat. So if you didn't understand everything in the first example, use that one, as you study the slide to force yourself to, okay, apply what you just learned, including the stuff that doesn't make full sense, and ask question, okay? We have here another example of a UML diagram. So this time we want a class that's going to model a TV. So for example, we are just building the next generation of Sims, okay? And we are going to have objects in our simulation, and some of them are going to be TV, and we are going to represent each of those TVs in the virtual simulation, as an object of class TV. And we need to discuss now, what does a TV need to know how to do? So the behaviors and methods, and what kind of data do we need to store inside of each specific TV in our simulation to keep track of what it's doing. So there we go, UML diagram, name of the class, TV, okay? And that's the ultimate in kernel case notation here because there's only uppercase and uppercase. Then attributes. What do we need? Well, the TV is going to be set on a channel, so we're going to keep track of that with an int. It's going to have a volume level, an int, and it's going to have a Boolean that tells us whether it's on or off. So we're going to call the attribute on, and it's going to be a Boolean. So if it's true, the TV is on. If it's false, the TV is off. And then a bunch of methods. So TV, same name as the class, that's going to be my constructor. So again, I haven't told you the whole story about constructor, just bear with me for now. Then I'm going to have a method turn on, and it returns nothing. That one is going to most likely, I can tell you already, change the value of on. So if it was off, now the TV is on. If it was already on, it's still on. And then reciprocally, I'm going to have turn off, and then I'm going to have a set channel method where I specify what channel I want the TV to be on. It returns nothing, but it's going to modify, probably the value inside channel here. And then set volume, channel up, that's going to increment the attribute channel for that TV by 1. Channel down, that's going to decrement it by 1. Volume up and down, that are going to do the same thing for the volume level. So there we go. This is how I'm going to model internally. So this has nothing to do with how I'm going to display on the screen the TV set or animate it in the game or something like that, right? But this is how I'm going to represent all the data in my application about what this TV is currently doing, what's going on with this TV object in my simulation, okay? Let's take a look at the code. So public class TV in a file named tv.java. Okay, we're good. We said all attributes are declared inside the class, but outside of any of its methods. So there we go. The first thing we do, int channel equal 1, int volume level equal 1, boolean on equal false. Okay. And I need to do a little remark here. This is how the textbook has you discover, one of your very first example of classes and how we initialize, default values for the attribute. And it sounds simple to put just equal 1 after channel and equal 1 after volume level and equal false after on. And it is, but this is not the way that I want you to do it in this class. So I'm going to explain that notation so that you can understand the example in the textbook. And then as much as I can, and there are cases where I cannot avoid it, but as much as I can, I will avoid using that kind of notation for initialization. Instead, I'm going to show you that in a few slides. It's inside the constructor here. So this is a constructor for my class, public TV. Inside the code of the constructor, instead of doing nothing, like the example from the textbook is doing, right? I would say channel equal 1, volume level equal 1, on equal false. Okay? One thing that is I would say every semester I have at least a handful of students that make that mistake at some point or another. So I'm going to go ahead and just give you a heads up, okay? Warn you about something that some of you might make as a mistake. If I want to declare attribute in a class, I declare them like variables here outside of any method. If I want to initialize them, there are two ways. One way, which is what the textbook is showing you on this example, is to put equal and a value after the declaration of the attribute. This is what we used before when we declared variable, right? Int x equal 42 that initialize x to 42. So this is kind of a remnant of what we used to do in COP2513. The second way to do it is inside the constructor, you would write channel equal 1, volume level equal 1, on equal false. So you would not have to put values here. You would not use equal 1, equal 1, equal false. But what I've seen a lot of students do in the past is they feel like they have to redeclare things inside this constructor or inside any method. Every time they want to use channel, for example, they feel compelled to say int channel. But there is a big difference. If you do int channel here, outside of any method, that's an attribute. If I was writing inside of public TV constructor, int channel equal 1, that would be a separate variable. That would be a local variable to that method, which happens to be our constructor. So each method could have inside of it a variable named channel. But you know what? When I play with that variable, that would not change the attribute channel. So try to avoid having name of variables inside the method, and this includes names of parameter that actually are the same than the name of the attribute. That can be actually a source of confusion, and that can mislead you to think that you have to redeclare all the time your attribute every time you want to use them. That's not true. In the class, you declare them one time, and then every method has access to them, without having to redeclare them. All right. So hopefully that will prevent some of you from making the mistake. For the others, the first time you encounter the mistake, I will point you out to what we discussed today, and it will make more sense. Okay, sometimes you have to commit an error, to make a mistake, to really fully appreciate and understand, why it's wrong. Okay, so don't worry. We'll have a lot of practice exercise where you'll have a chance to stumble across this kind of stuff. All right. Continuing in our implementation of the class TV, what do we have? So the turn on method, turn off method. So what do? They change the value of the attribute on equal true or on equal false. The set channel, same thing. You give me a new channel and I assign it to the attribute channel. But look at this. In addition, I don't blindly accept any value for the parameter. What I do is I check if the TV is on, because if it's not on, I'm not going to set the channel to a new channel. It's like you pressing the number, keypad on your remote. If the TV is not on, this is not changing anything on the TV, right? So I'm going to first check that if you call set channel on a specific TV object with a value for a new channel, I'm going to first check that the TV is on. If on is false, then that failed. I don't do anything. If on is true, then I'm going to check that on is true and the value of new channel is greater or equal to 1. So you don't give me a negative channel, for example. And if that's false, again, I abort. But if it's true, then I check again and new channel lesser or equal to 120. I limit the number of channels to 120. If you satisfy those three conditions, then I agree. I'm going to assign to the attribute channel the value that you gave me as parameter. So what did I do here? I protected the ability to change the channel on my TV object. Okay, I didn't just take a parameter and assign it. I wrote this method set channel so that it would verify that the parameter you give me actually makes sense and that the TV is on and that all of those things that need to be in place before I can change the channel, right? That's actually another interesting feature of object-oriented programming, because now my TV objects, I can write them in a way that allows them to protect themselves from misusage. If somebody tries to set the channel and it's not on, nothing bad is going to happen. If somebody tries to set the channel to minus 500, I'm not going to change the channel. Sorry. This was just a mistake and you're going to have to deal with it because I'm not changing that channel. So you see how you can start pretty much writing code that defends itself from abuses, okay, from misusages. Question in the chat. Shouldn't it be if on equal true? Yes, you could write if on equal true. Okay, that would be perfect Java, very clear, very readable. But you can also write if on, because what you do is you have an expression, right? Like on equal true. You want to know if it's true or false, that expression. So you evaluate the content of on, which is true or false, and you compare it to true with equal true. And then it gives you a value that is true or false, a Boolean value. Well, here I'm kind of skipping steps. Since if on is equal to true, I'm going to get true. And if on is actually containing false, I'm going to get on equal true resulting into false. Then I can just look directly inside on and see what's in there. And if it's true, then the expression is true. If it's false, it's false. So you are going to see people use things like that. If the name of a Boolean variable, that means if the Boolean variable contains true, or maybe sometime if exclamation mark, okay, meaning the negation. If not, and the name of the variable, then that means if the variable contains true, then it's false. If it's false, it's true. Okay, you negate the content of the variable. So you're going to see people using those kind of shortcuts right and left. But if you want to write it equal true, that's perfectly fine. Okay, so don't let me discourage you from writing it that way. This is very clear. There's no potential for misinterpreting. That's good code. And then same for the volume. The volume has a range from 1 to 7. So I can implement the constraints here that say you cannot change volume except if the TV is on. Then the volume has to be greater or equal to 1. Then the volume has to be lesser or equal to 7. If all those conditions are met, then I update the attribute volume with the new value that you gave me. So an object can have methods that allow you to go and modify attribute. And guess what? Those methods, they can protect to ensure that the attributes are going to be, for example, always within a range. So we are starting to be able to write code that defends itself from, like I said, abuses, misusage. And then what do we have next? We have the channel up, same idea, okay? I'm going to go a little fast on that. Channel up, channel down, volume up, volume down. Again, I verified that what we're trying to do makes sense. And if it does, I increment channel by 1 or decrement it by 1, increment volume by 1, decrement volume by 1. Now, what do I do now that I have this code? Well, I'm going to test it. And I'm going to use a different way to test just to illustrate, the different ways we can test classes. In the previous example, my first testing option was I write a class and I just want to go ahead and test it right away. So I put the main method inside the class. The problem with that is if that class was meant to be given to other programmers, the first thing they would do if I share it with other programmer is they're going to erase my main method because they are not interested in whatever code I use to test my own class. What they are interested in is they are trying to do something with their app. So they already have their main method. So it's generally I mean, you see that done a lot in Introduction to Programming class because it's easy. So a lot of textbook, have you write a class and then write the main method inside that class, and the main method test the method of the class that you just wrote, right? And it's all in one file, and it's nice as a beginner. You don't have to worry about much. But most of the time, what you want to do is you would want to have a separate class. Okay, so for example, if my class name is TV, I'm going to have a class named Test TV or TV Test. Okay, different company and different testing framework have different conventions. Bottom line is that you are going to find the name of the original class in that name, plus something that mentions that this overclass is only meant to test the first one. And inside that class, you can have attributes, you can have method if you need them, but most importantly, you are going to have a main method. And that main method here is going to actually do all the work of testing, the class TV, making sure we can create object of class TV, making sure that, when the volume is at 7, we cannot go beyond that and stuff like that. So there's a lot of stuff we could write here to test, that class. What I have on this slide, I have just the bare minimum. The bare minimum meaning that the main method declares a reference variable named TV1 of type TV. So it's meant to hold a reference to an object of class TV. I create a first TV object, put the reference in TV1. I turned on my first TV, set the channel to 30. So that's going to work because the TV is on and the value 30 is acceptable. Then set the volume to 3. And then I'm going to declare another reference variable TV2 that's going to be meant to hold a reference to an object of class TV. And I create a new TV object, TV2.turn-on. I turn that TV on, so that doesn't change anything for TV1, right? TV2.turn-on, TV2.channel up and up. So the default channel was 1, so now it should be 2, 3, and then volume up. The default volume is, I don't remember, I think it's 1. So it's going to go from 1 to 2. Okay, so I have two separate TV objects that have been built from the same pattern, okay, the class TV. So they contain the same type of attributes. They have access to the same method. And now I can use them separately and say, for example, okay, this is what I have for TV1. This is a channel. This is a volume. And this is what I have for TV2. This is channel and volume. And this is really the bare minimum amount of testing, okay? I should be testing a lot more stuff, but at least I can compile and run this and make sure that, I did create the object, my program didn't crash, and then each of the object has the settings that I thought it would receive. Okay, so if I messed up my default values or something like that, this is how I'm going to realize it. Okay, so again, very, very, very minimalist test. What I would like to test is after I'm done doing this, I would love to call, for example, volume up on TV2 10 times. 10 or 20 times even, I don't care. Bottom line is that I'm going to keep pressing the volume up key until what? Until I reach a maximum of 7. So after I'm done calling, let's say 10, 15, 20 times volume up on TV2, then I would display again system.out.println, and I would say the TV2 channel is blah, and the volume level is blah. And I would visually inspect that even though I called volume up, an insane amount of times, the volume never went past 7. Then I could test similarly that I cannot get a volume to go below 1, that I cannot get a channel to go above 120, that I cannot get a channel to go below 1. And then I could even start turning the TVs off and try to change the channel and the volume while they're off, and then display again their data to make sure that nobody is able to change the volume or the channel while the TV is off. Okay, so all of that goes back to what we discussed, already earlier in the semester and in COP2513, which is when you write code, it's not good enough for you to write the class TV. Okay, if you write the class TV and you ship it to your client, to your boss, to your coworkers, for them to use, they're going to come back and they're going to be really upset. They're going to be really upset because it's really rare that you write a class without, testing it and it works. So you need to do all the work of testing your own code. You need to do all the work of actually trying to figure out how and when your code can break. And so that means, using that critical thinking ability that you all have and get in there and try to figure out what could possibly go wrong. Changing a channel when the TV is off. I should not change the channel. And you're going to write code like this that's going to allow you to actually stress test pretty much your class TV until you are confident that you did your best to break it and it still didn't break. So now you're confident, you pass your code along to the next person, and chances are that that person is going to think about a totally different test and then come back to you and say, hey, you are failing my test. That's okay. That's part of the process, right? Now I have a new set of eyes that have been looking at my code, a new person that has been trying to use my code, and now I'm going to be able to discover that, well, what I thought was working, yeah, there's still some problems. So I'm going to go ahead and fix that and then release a new version of my class. Okay. So this is this idea of testing that we have been using since COP2512, but with a flavor that is object-oriented programming, which is every time you write a class, you should have another class, which only goal is to make sure all the methods of that first class actually do what they are expected to do. All right. So right in time, which is really odd for me because usually I go over. So we are going to wrap it up here. Like I said in the announcement, and I hope everybody saw that, what we do at the end of the lecture during those 2 weeks where we are back to an online format is I transition immediately to office hours. So I'm going to stop the recording right now, and hopefully, finger crossed, the recording went okay. And we are going to transition to office hours. So don't go anywhere if you have any question. Just hang around even just 5 minutes to tell me what's bothering you, etc. And we can work on that right now. And I won't record that. So office hours will not be recorded. But the rest of the lecture will be posted as soon as I have a chance to process it. All right? Well, thank you, everyone. I hear that there are some questions on the chat. I'm going to first stop the recording, and then I'm going to open the floor for more questions and address the ones that are already there. All right. Thank you, everyone.